Okay, in this video I'm going to go through partial fractions. So partial fractions are in the following form. So let's do a question. So let's say we have 2x minus 3 over x plus 1 x minus 2. Okay, so we have to split this into two fractions. So this must have come from a over x plus 1 plus b over x minus 2, because if you're adding these two fractions you would get that as the partial fraction. So let's try and make this work now. So if you want to do the common denominator here, x plus 1 x minus 2, so that makes it a times this, which is x minus 2, plus b times that, which is b times x plus 1. Okay, so now if you simplify, actually we don't have to simplify, we can keep it in this form. So the numerator here has to equal to the numerator there, so that means 2x minus 3 equals a times x minus 2 plus b times x plus 1. Now you can solve this in two ways. You can solve this simultaneously. You can open this up, make the x terms equal to the x term there, and the number terms equal to the number term there, and get the a and b that way. But I'm going to use the elimination method, which is the easier method out of the two. So when x equals to 2, now the reason I chose 2, if I put 2 in here, 2 minus 2 is going to be 0. So a is going to disappear, so we're going to get something in terms of just b. So you see what happens. So this side becomes 2 bracket 2 minus 3, and here is going to be 0, so we end up with 2 plus 1 is 3, so equal to 3b. Okay, so that means 4 minus 3, which is 1, equals to 3b. So b equals to 1 over 3. So this b here is 1 over 3. Now I can do the similar thing and do when x equals to minus 1. You can see minus 1 plus 1 here, so the b is going to disappear. So let's work it out. So 2 times minus 1, so 2 bracket minus 1 minus 3 equals to a bracket minus 1 minus 2. So 2 times minus 1 is minus 2 minus 3 is minus 5, equals to minus 3a. So that makes it 5 over 3 equals to a. So my a is equal to 5 over 3. So this fraction here is equal to, so instead of a I can write 5 over 3. So it will be 5 over 3 bracket x plus 1. Instead of b I can write plus 1 over 3 bracket x minus 2. And that's my answer. So that's how we do partial fractions. Okay, so let's try and do a slightly more complicated fraction this time. Okay, I just hope I have enough space on the board. Okay, so let's get rid of this. So if you want to copy this down, it's up to you. Okay. So you can get 3 brackets as well, or you could get multiple brackets. You can have as many brackets as you want, so you just have to simplify it. So it's not a difficult thing to do. Okay, so let's do a question like this. Let's say we have 2x minus 3 over x plus 2 squared x minus 3. Okay, now that's an interesting question. So the 3 possible fractions here are a over x plus 2 plus b over x plus 2 squared plus c over x minus 3. Okay, so let's go through that again. So if you look at the common denominator here, it's going to be x plus 2 squared x minus 3, because you have an x plus 2 squared here, so that one actually goes to that one, but then these two together will give you the common denominator there. So we have to split it this way because you can't possibly have these three fractions. Okay. So now let's just sort this out in a common denominator. So if I put them all under the common denominator, x plus 2 squared x minus 3. So a has to be multiplied by x plus 2 and x minus 3. Because there's only a single x plus 2 here, so to make it a square I need to multiply that by that. Now b is already a x plus 2 squared underneath that, so I just have to multiply it by x minus 3 here. And then c, I had to multiply it by the x plus 2 squared because c's only got x minus 3 underneath that. So there you go. Okay, so it's slightly more complicated. Okay, so let's just write the numerators. So 2x minus 3 equals a bracket x plus 2 x minus 3 plus b bracket x minus 3 plus c bracket x plus 2 squared. Okay, so now let's use the elimination method again. So if I put x equals to 3, this is going to be 0, that's going to be 0, so you're going to end up with just with that. So when x equals to 3, so 3 times 2 is, so let's just write this down, minus 3, so that's going to be 0, that's going to be 0, so this is only thing. So 3 plus 2 is 5 squared. Okay, so we're going to get 6 minus 3, which is 3 equals to 25c. So c equals to 3 over 25. So I already got my c. Now let's just get the other two things as well. Let's do it here. So if I put x equals to minus 2, that's going to cancel and that's going to cancel, and that's going to get you a b. So when x equals to minus 2, so it's going to be 2 minus 2 minus 3 equals to, so that's going to cancel, you end up with just that, so it'll be b bracket minus 2 minus 3. Okay, so we have minus 4, minus 3 is minus 7, and this is minus 5b, so the minus and minus cancel, so 7 over 5 equals b. So I got my b sorted out. Okay, now I cannot use any more substitutions to cancel anything because I already used both possible numbers. So since we already know b and c, we can actually substitute 0. So when x equals to 0, so the right hand side becomes, sorry, the left hand side becomes 2 times 0 minus 3. So I don't know a, so it's going to be a times 2 times minus 3. I know my b is 7 over 5 times minus 3 is going to be minus 21 over 5. I know my c, which is 3 over 25, but here it's going to be 2 squared is 4, 4 times 2 is 12 over 25. Okay, so here we have minus 3 equals to minus 6a minus 21 over, okay, let's just simplify this. So this is minus 105 over 25 plus 12 over 25. So it's minus 3 equals to minus 6a minus 93 over 25. So if I add that to that side, let me make that under 25. It will be minus 75 over 25 plus 93 over 25 equals to minus 6a. Okay, so that is 18 over 25 equals to minus 6a. So if I divide by minus 6, it becomes minus 3 over 25 equals to a. So there you go, that's your solution. Okay, so this is just algebra here. I hope it's clear. So this is how you do partial fractions. So I've done 2 examples, one simple example and one complicated one. If there are any questions, please send me a message or a comment below, and I hope it helped you. And keep practicing these, and you're likely to get a question like this at least on its own or in an integral question, because we need to do integration by partial fractions as well. Okay, then I'll leave it there.